Hello, welcome students. Today I am going to introduce the topic electrochemistry. In this video, we will mainly discuss introduction part, functioning of electrochemical cell, electrode potential, and measurement of electrode potential. We will first start with introduction part of electrochemistry. Electro means electricity, whereas chemistry means chemical reaction. So, electrochemistry is the study of production of electricity from energy released during the spontaneous chemical reactions and use of electrical energy to bring about non-spontaneous chemical transformation. The reactions carried out electrochemically can be energy efficient and less polluting. Therefore, the study of electrochemistry is important for creating new technologies that are eco-friendly. As we have, as electrochemistry is the study of electricity with the help of using chemical reaction. So, by doing this, electrochemistry can be energy efficient and less polluting in nature. Due to this, some technologies which can be based on electrochemistry will be eco-friendly in nature. Electrochemistry can relate with two main functions of energy. First is chemical energy when converted into electrical energy. Then after conversion of chemical energy into an electrical energy, the cell which is formed are known as galvanic cells. They are also known as voltaic cells or they also known as electrochemical cells. Second, when electrical energy gets converted into chemical energy. When electrical energy converted into chemical energy, the cell which is formed are known as electrolytic cell. Here we will start with electrochemical cell or galvanic cell. The devices in which electrical energy is produced from chemical reactions are called electrochemical cells or galvanic cells. Means when chemical energy gets converted into electrical energy, then the devices which are formed or the cells which are formed are known as electrochemical cells. As in class 11th, we studied one topic that is redox reaction. Redox reaction has two parts. One is oxidation part and other one is reduction part. So on the same, electrochemical cell will work on the phenomena of redox reaction. In these cells, oxidation and reduction reactions occur in a separate container called half cells. The separate containers on which the reduction and oxidation taking place are known as half cells. And redox reaction is spontaneous in nature. This can be shown with this diagram also. Here, two containers are given, and in these two containers, in one container, the zinc rod is present in a solution of ZnSO4. Since zinc is a metal and this metal rod is placed in a solution of ZnSO4, the metal rod placed in the solution, that solution is known as electrolyte. In which the metal rod is placed, that solution is known as electrolyte. Similarly, in another container, we have copper as a copper rod, and this copper rod is dipped in a solution of copper sulfate. This is known as electrolyte, which is a salt solution of copper, CuSO4. Now, since zinc has a tendency to lose electron than copper, zinc has more tendency to lose electron than copper. So, zinc will behave as anode. Zinc electron will behave as anode, whereas copper electrode, as it has less tendency to lose electron, so copper electron will behave as cathode. And we know that in redox reaction, the electrode which act as anode, oxidation reaction will takes place in that electrode, and the electrode which act as cathode, on that electrode reduction reaction will takes place. So from here the half cell reaction of anode for zinc will be zinc metal loses 2 electrons, gives zinc 2 positive ion, whereas the copper ion gains 2 electrons because it is a cathode compartment. It is in cathode compartment, so copper ion gains 2 electron and gets converted into its metallic form. So this is all about electrochemical cell and representation of electrochemical cell. And electrical energy is produced during such reaction. And yes, when electron flow from zinc to copper, since the electron is flowing from zinc to copper like this, then the current will flow in opposite direction. And from here the electrical energy is produced by the reaction. Here we will see functioning of the cell when external opposing potential is applied. Suppose we have the arrangement, similar arrangement as we have discussed earlier, that zinc and act as anode and copper metal act as cathode. And the electrode potential for this will be 1.1. If the electrode potential which is fixed and it is 1.1. Now, if we apply the external electrode potential to that particular cell and which is less than 1.1, then what will happen if the electrode potential is less than 1.1? Then the the electrochemical cell will work continuously. Electrochemical cell continuous working, and the electrons flow from zinc to copper rod. Hence, current flow in opposite direction means current flows from copper to zinc side. Zinc will act as anode and copper will act as cathode. From here, since the external pressure is low, so the cell will always work to achieve the potential difference, that is 1.1. If the external pressure is less than 1.1, then the cell will work and it will work till it achieve 1.1 volt of potential, and cell will work in the same direction where the electron flow from zinc to copper, current flow in opposite direction, copper to zinc side, and zinc act as anode and copper act as cathode. And when the condition, as we changes the condition, when external potential is equal to 1.1 volt, now what will happen if the external pressure we applied is equal to the potential of that cell which is containing zinc and copper? If the external pressure gets equal, or we applying the external pressure equal to 1.1 volt, then no electrons will flow and the cell will not work. No chemical reaction will be there. Why it is so? It is due to the external pressure becomes equal to 1.1, then the cell will not work in this case. And no flow of electrons, so no current will flow and no chemical reaction will takes place. In third case, when external potential will greater than 1.1 volt, then what will happen? As we increase external potential, now again starts the reaction. In second part, the cell potential becomes equal to 1.1, but as we now we are increasing the external potential, then as on increasing the cell potential again, the cell reaction will starts, but in opposite direction, because the external potential we are applying, it is already higher than the actual potential of the cell, which is 1.1. Therefore, all the cell reaction will get reversed. The cell now start functioning as electrolytic cell. Why it is electrolytic? Electrolytic cells are those in which electrical energy converted into chemical energy, and your electrode potential is much more than your actual potential of the cell. Now it will get converted into chemical energy. That's why the direction of all the electron and direction of current will reverse, and the cell will work as electrolytic cell. In this, electron will flow from copper to zinc in opposite direction, and current will flow from zinc to copper. Zinc is deposited at zinc electrode and copper is deposited at copper electrode. It means here zinc acts as cathode and copper acts as anode. Anode is positive terminal here and cathode is negative terminal here. So the cell which is formed by such type of arrangement are known as electrolytic cell. Here is the representation of an electrochemical cell. Suppose we have a redox reaction. Zinc plus copper ion gets converted into zinc ion plus copper ion, and we have to represent this equation into an electrochemical cell pattern. How will we represent this? For representation of an electrochemical reaction, we have to notice one common thing, that suppose this is a electrochemical reaction and the electrochemical reaction is always divided by a bridge, that is called salt bridge. The left hand side of the salt bridge is denoted as anode. Left hand side of this salt bridge is known as anode, and right hand side of this salt bridge is known as cathode. In left hand side, oxid it is anode, so oxidation takes place and the terminal is negative. Right hand side, reduction takes place and the terminal is positive, it is cathode. As a memory aid, keep in mind the alphabetical order of first letter, that is A. A means anode, comes before C, cathode. It means anode will always place on left hand side of the salt bridge, and after anode, cathode will place on right hand side of the salt bridge. So the representation of this equation, zinc and copper, can be as, since as we have seen that zinc in an electrochemical cell of zinc and copper, zinc behaves as an anode, oxidation of zinc takes place, and copper acts as cathode, reduction of copper takes place. So this is the junction between these two half cells. This is the salt bridge. So left hand side of the salt bridge will acquire by zinc compartment, because oxidation or anode will come at left hand side, and right hand side of the salt compartment, right hand side of the salt bridge will be acquired by copper compartment, because it is a cathode and reduction is taking place in this compartment. So this is this representation of an electrochemical cell. Now after representing the electrochemical cell, we will discuss electrode potential of a galvanic cell or an electrochemical cell. A potential difference develops between the electrode and the electrolyte, which is called electrode potential. The electrode potential, the potential difference develops between electrode and the electrolyte is the electrode potential. When the concentration of all the species involved in a half cell is unity, concentration of all the species present in a half cell is unity, then the electrode potential is known as standard electrode potential. Means if the concentration value of all the species of half cell is equal to 1, then such type of electrode potential are known as standard electrode potential. Thus, the electrode potential is a measure of tendency of an electrode in a half cell to gain or loss of electrons. It means electrode potential has a tendency, it is a measure of a tendency of an electrode in a half cell. Half cell is either oxidation or a reduction to gain or loss of electrons. The electrode potential can be of two types: oxidation potential and reduction potential. There is one term is also there, that is cell potential of a cell, or EMF, electromotive force. The cell potential is the difference between the electrode potential, that is reduction potential, of the cathode and the anode. It is called the cell electromotive force, EMF, of the cell when no current is drawn through the cell. It is expressed in volts. EMF is equal to reduction potential of cathode minus reduction potential of anode. EMF equal to, it is represented as E, so EMF equal to E of cathode minus E of anode, or it is also known as potential of cell. So E of cell equal to E of right hand side, because at right hand side cathode is present, minus E of left hand side. Left hand side is anode is present, that's why E of right minus E of left. This is illustrated by the following example. Suppose we have a reaction copper plus twice of silver ions plus copper ion gives copper ion plus 2 molecules of silver. Then half cell reactions for this, as copper is going, loss of electron is present in copper, so it is oxidation, and this is reduction, gain of electron in silver. So this is reduction. Cathode reduction half cell reaction is for silver, and anode oxidation half cell reaction is for copper. So EMF of cell for this reaction, EMF of cell comes out to be E cell will be equal to E of cathode. Cathode here is for silver, so E of cathode, that is silver, minus E of anode, here it is copper, so E of anode, copper. As we have discussed two terms, electrode potential and electromotive force, that is cell potential. So the difference between EMF and EMF and potential difference are: EMF is the maximum potential difference between two electrodes of the cell when no current is drawn from the cell, that is when the circuit is open. And the potential difference is the difference of potentials between two points in a closed circuit. When the circuit is closed, then we can find potential difference, and when the circuit is open, when there is no current, then EMF, electromotive force, can be calculated. EMF is an independent of the resistance of the circuit, whereas electrode potential is proportional to the resistance between the given points. The term EMF is used only for source of EMF, electromotive force, and whereas electrode potential is measured between any two points of the circuit. It is greater than the potential difference between any two points of the circuit. EMF is always greater than the difference between any two point of the circuit, where however potential difference is greater than EMF when the circuit is being charged. So these are the difference. Now we will discuss the measurement of electrode potential. How can we measure the electrode potential? The potential of individual half cell cannot be measured individually. We can measure only the difference between two half cell potentials, that gives the EMF of the cell. The potential of individual half cell can't be measured. We can only measure the difference when there are two half cells are present, and that gives the cell potential of the cell, or the EMF of the cell. As we have discussed, what is the EMF? EMF is the difference between two half cell potentials of the cell. Now, according to convention, the electrode potential of an electrode can be determined by connecting this half cell with a standard electrode. Suppose we have only one half cell and we have to find out the electrode potential of that individual half cell. As it is not possible to find out the electrode potential of an individual half cell, so what will happen, we will have to connect that individual half cell with a standard hydrogen electrode. Now first of all we have to learn what is a standard hydrogen electrode. The electrode potential of a metal electrode as determined with respect to standard or normal hydrogen electrode is called standard hydrogen electrode, and it is denoted by E naught, standard condition. The electrode potential of a metal electrode is determined with respect to standard or normal hydrogen electrode is called standard hydrogen electrode. It is denoted by E naught. The electrode potential for standard hydrogen electrode is taken as 0. Now it will be easy as the standard electrode potential of standard hydrogen electrode is taken as 0, and then it will be easy for us to find out the electrode potential of one half cell by connecting it with standard hydrogen electrode. Now let's see standard hydrogen electrode. The standard hydrogen electrode consists of a platinum electrode coated with platinum black. The electrode is dipped in an acidic solution and pure hydrogen gas is bubbled through it. You can see in the image also. This electrode, it is dipped in the solution which is acidic in nature, and pure hydrogen gas bubbled through it. These are the bubbles of hydrogen gas. As we put this electrode to the acidic solution, hydrogen gas can bubble. The concentration of both the reduced and the oxidized form of hydrogen is maintained at unity. This implies that the pressure of hydrogen gas is 1 bar because it is maintained at unity. So it implies that the pressure of hydrogen gas is 1 bar and the concentration of hydrogen ion in the solution is 1 molar. This can be seen in the image also. The pressure of hydrogen ion is 1 bar and the concentration of hydrogen ion is 1 molar. From this, the equation comes out for standard hydrogen electrode, that is hydrogen ion H positive, which is in aqueous solution, gains 1 electron and gets converted into hydrogen gas, means it hydrogen gas in the form of bubbles like this. Since if I have only zinc electrode and I have to calculate the electrode potential of zinc electrode, so what will I do? I connect zinc with the standard hydrogen electrode, so that I can find out the value of electrode potential of zinc electrode. In this case, the measurement of electrode potential of zinc electrode is here. This is the diagram for measuring the electrode potential of zinc by connecting zinc metal with a standard hydrogen electrode. This is the standard hydrogen electrode here. In this case, the electron flow from zinc electrode to hydrogen electrode. So zinc electrode starts as anode and hydrogen electrode, which is a standard hydrogen electrode, SHE, act as cathode. Because in electrochemical series, zinc lies below with respect to hydrogen, and the elements which are lying below with respect to hydrogen in an electrochemical series, they act as anode. Why they act as anode? Because uh, their reducing agent, their reducing tendency increases, and they behave and oxidation will take place for such type of compound which lie below to the hydrogen in an electrochemical series. So similarly here, zinc electrode lies below hydrogen in an electrochemical series, so zinc electrode act as anode and flow of electron will takes place from zinc to hydrogen side, which act as cathode. The cell may be represented as this is salt bridge and left hand side of the salt bridge as anode, as zinc act as anode. So zinc its ion which is 1 molar, and right hand side of the electrode is we will represent in a cell as cathode, and here cathode is hydrogen electrode, and hydrogen electrode has hydrogen ion, hydrogen gas and platinum. From here the cell potential of cell E naught of cell will be equal to E naught of right hand side minus E naught of left hand side. We have discussed earlier, since the cell potential of zinc equal to 0.76 volt. This is the value of cell potential of zinc. But on putting the value of this to the equation of cell potential, standard cell potential, we will get that standard cell potential for hydrogen is 0 as we have discussed earlier, and for zinc the value is 0.76. So on solving this equation we get the value that is minus 0.76 volt. This means that the standard electrode potential for zinc is minus 0.76 volt. Similarly, for measurement of electrode potential of copper electrode, if I have to measure only half cell of copper, so I will connect copper electrode with again with standard hydrogen electrode, again with hydrogen electrode. Now in this case hydrogen has greater tendency to lose electrons in comparison to copper, because in electrochemical series copper lies above to hydrogen, and the elements which are lying above to hydrogen, they have greater tendency to lose electrons, so they behave as cathode. The reduction reactions takes place for such type of elements. So here also copper, as copper lies above the hydrogen in electrochemical series, so cop, for this hydrogen has greater tendency to lose electron in comparison to copper. So oxidation occurs at hydrogen electrode and reduction occurs at copper electrode. From this the cell may be represented as this is the salt bridge, and left hand side of the salt bridge as cathode, anode sorry, left hand side of the salt bridge will act as anode, and here anode is standard hydrogen electrode. We will represent in left hand side, and right hand side is as cathode. Here cathode is copper, so right hand side is act as copper chamber. You can see also this with this image also. Here copper act as cathode and hydrogen act as anode. Why? Because hydrogen has greater tendency to lose electron, and electron will flow from hydrogen to copper. Why? Because copper lies above in the above to hydrogen in an electrochemical series, and due to this it behaves as cathode. Reduction will takes place. Reduction in case of copper takes place. Now from this the E naught of cell will be equal to E of right hand side minus E naught of left hand side. As we know that since the cell potential of copper is 0.34 volt. Now on putting this value to this equation, right hand side is of copper and left hand side is of hydrogen. On putting these values, 0.34 minus 0 E naught of standard hydrogen electrode. So value E naught of cell potential for copper will comes to be 0.34 volt. Thus the standard electrode potential for copper is positive 0.34 volt. From this it may be calculated that the electrode at which oxidation occurs, this is important, the electrode at which oxidation occurs with respect to standard hydrogen electrode has negative reduction potential, as we have seen in case of zinc. The value of standard reduction potential for zinc comes to be minus 0.76. So the electrode at which oxidation occurs with respect to standard hydrogen electrode has negative reduction potential, and a negative cell potential means that the redox couple is a stronger reducing agent than hydrogen couple. That's why in an electrochemical cell, the elements which are lying below with respect to hydrogen shows stronger reducing agent tendency because they have negative reduction potential. Now come to next, the electrode at which reduction occurs with respect to standard hydrogen electrode has positive reduction potential. At which the reduction occur with respect to standard hydrogen electrode has positive value of reduction potential, as we have already seen in case of copper, where copper act, act as cathode, so reduction of copper occur. For that we got the value of standard electrode potential of copper, that is positive 0.34 volt. And the positive electrode potential means that the redox couple is a weaker reducing agent than hydrogen couple. So this is all for today, and in our next videos we will discuss its further topic. Thank you.